Hello everyone, welcome to the Mechanism channel. Today's topic is tolerance. Tolerance in manufacturing and engineering refers to the permissible variation in the size, shape, or position of a part from its specified dimensions. It defines the allowable limits within which a part can deviate from its nominal or ideal dimension while still functioning as intended. Tolerances are critical to ensuring parts fit together properly, work reliably, and are economically feasible to produce. Key aspects of tolerances: nominal dimension, the ideal or target size or measurement specified on a drawing. For example, 50 millimeters. Upper and lower limits, the maximum and minimum allowable deviations from the nominal dimension. Tolerance range, the total difference between the upper and lower limits. For example, if the tolerance is plus or minus 0.05 millimeters, the part size can range between 49.95 millimeters and 50.05 millimeters. Types of tolerances: dimensional tolerances. Linear tolerance specifies allowable variations in the size or length of a feature. For example, plus or minus 0.1 millimeters for a 100 millimeter part. Angular tolerance specifies allowable variation in an angle. For example, plus or minus 1 degree for a 90-degree corner. Geometric tolerances, or GD&T, stand for geometric dimensioning and tolerancing. Form tolerances allow variations in the shape of a feature, such as flatness or straightness. Orientation tolerances control how one feature is oriented relative to another. For example, perpendicularity or angularity. Location tolerances define the allowable deviation of the position of a feature, like the position tolerance of a hole. Runout tolerances control how much a surface can wobble or deviate during rotation. Fit tolerances are used to describe how two parts, like a shaft and a hole, fit together. For instance, we have a clearance fit where parts slide or rotate freely. Then there's an interference fit where parts are pressed together tightly. And lastly, a transition fit, which may either allow movement or create slight interference. Let's look at an example. For a part with a nominal dimension of 50 millimeters and a tolerance of plus or minus 0.1 millimeters, the upper limit would be 50.1 millimeters and the lower limit would be 49.9 millimeters. This means the part is acceptable if its size is anywhere between 49.9 millimeters and 50.1 millimeters. Why are tolerances important? Well, they ensure functionality by making sure parts work together, especially in complex assemblies like engines and gears. They also allow for interchangeability, which is crucial for mass production of parts. Moreover, tight tolerances can increase manufacturing complexity and cost, so they must be carefully balanced with the functionality required. And finally, they provide clear criteria for quality control, helping in inspecting and accepting parts. Tolerances are specified in design documents, such as engineering drawings, to guide manufacturing and quality assurance. Thanks for watching. Please like, share, and subscribe. Happy learning.